My topic today, we're going to have a look at straight line graphs. Now in the UK we tend to call straight line graphs y equals mx plus c, but we also find in other countries people use y equals mx plus b. So doesn't matter where you come from, the maths is exactly the same. I in fact like C, and I'll tell you why in a minute, but I don't like M. M is our gradient, and if I was doing this, then gradient would be G, and C is where it crosses the y-axis, and I don't see where B is a good name there, although in the UK many maths teachers call this the y-intercept, which doesn't tend to help either. So I'm going to use y equals mx plus c because I'm used to doing that and I normally do that, but for any time I say c, then B is just as relevant. Okay, let's look at a graph, and what I'm going to do here is I'm just going to draw in a simple graph. Now I'm doing this on squared paper so you can see, and let's just put in a little line here. So if I were to mark in some numbers here, then if we look at this line we can see that every time we go along 1 we go up 1, along 2, up 2. So this is the graph of y equals x. There's no mx plus c, there's nothing else. That is the simplest of the line graphs. So whenever we work out one value, we can immediately work out the next. The gradient here we always measure, and the gradient equals the rise over the run, the number that we go up over the number we go along. So if I were to look at this point here, then we've gone here along 2 and up 2, so we put in our rise, which is going to be 2, over the run, which is going to be 2, and that gives me 1. And so if we try to do this as an equation, then this is y equals 1x, and as we know we wouldn't write it like that, but instead we write it like y equals x. So it's not particularly difficult. Let's have a go at another one. So we'll draw in another graph, but this time what I'm going to do is I'm going to draw in a line with a different gradient. Let's put in our numbers again. And let's have a look at what this graph is. So this is the graph of y equals mx. Let's see if we can work out what this m is going to be. I've made life easy at the moment because I've set b or c to be equal to going through 0, so we're going to ignore them for the time being. So let's look at the rise and the run. So I've got my rise over my run. The rise is 1, 2 over the run, which is just 1, and 2 over 1 is 2. So this is the graph of y equals 2x. Now, I hope you didn't find that one too difficult. So let's now see if we can change something on that graph and make it a little bit more complicated. So what I'm going to do is I'm going to take this graph here and I'm going to draw another line on here. Now I've drawn in a parallel line. So if they're parallel to one another, then we would know that they've got the same, they'll never touch, they're going to have the same steepness, and so these lines here are going to have the same gradient. But here it's going to cross the y-axis, where it's going to be the y-intercept, or b, take your pick. So this is going to give us, this time, the graph of y equals 2x plus 2. So this value of the y-intercept, b or c, is very easy to work out. So let's try another graph and see if we can cope with that one. Let's put in a line. Students do tell me that I press too hard on pencils, and they are absolutely right. This time we're going to do a graph going in something in the opposite direction. So let's just line this up so it looks reasonable, and let's put in our numbers. So let's zoom out just a tad so you can see that a little bit better. Right, now what I want to do is work out the equation of this line. And I now have a sharp pencil again. We're going to take our gradient. We're going to work out, just as before, y equals mx plus c b. Now it crosses the y-axis, the y-intercept. This is b or c, so we know that's going to be 6, but we're going to work out first of all m. M, we said, is the rise over the run. Our rise here is going to be, well, let's look at a certain bit here. Let's just look at this bit. My rise is, going down 2. So it's going to be minus 2 over 1. So this is going to give me y equals minus 2x plus 6. And that gives me here my equation of my line. Students ask me how can you easily work out how and which one is which, whether it's positive or negative, and that's really easy. If you're looking at a business and it's doing well, you might see it going on the sort of up and up, and this is here very looking positive. We call it sometimes a positive correlation if we're drawing points up here, but this is a positive gradient. Whereas if I was looking at how my company could be doing, and it's sort of doing this, and we have to tack extra bits of paper on the bottom, then you know it's doing very poorly, and this is negative. So we can think of this by thinking about how a company is doing. If it's doing well, it's on the up and up, and it's going down, it should be negative. So we can get quite a few graphs to have a look at, and we can get the idea about quite a lot of graphs simply by having a look at them. So I've got another little graph here, and let's do one that looks perhaps like this. So I'm going to line it up, and let's put some numbers in. This is the graph of, let's just push this up a bit, y equals the rise. Let's just look at this little point here. You've got to choose points where they cross lines. So y equals the rise, which is 1 over the run, which is 2 x. So this is going to be y equals a half x. If I draw in a line that's parallel to this, then this is the line of y equals a half x plus 2, because it's going through the line there. And if I had another line, these are all parallel lines to one another, this is going to be the same gradient because these are all parallel, so this is y equals a half x plus 3. I hope you can see that that's quite an easy way of trying to work out the equation of a line from a graph. So it's going to go this way, it's going to be negative, that way it's going to be positive. So these are parallel lines. How about perpendicular lines? So let's draw in a graph. And let's put in a line. Looks reasonable there. And we'll draw in a line that's going to be perpendicular to this one. And if I put my 6-inch marker there, it gives me a much longer line. Then what I can do is, let's just draw in a perpendicular line. Let's work out the equation of this line. This is y equals the rise over the run. So the rise here is 2, the run is 1, so this is 2x, and it's not crossing the y-intercept, the y line, anywhere other than 0, so I can just leave that out. As for this line, let's look at what this one is. So let's take a little point to have a look at it. This is y equals the rise, which is going down 1, so it's minus 1 over the run, which is 2, a half x, and it goes through the point 2. Now, these two lines are at 90 degrees to one another, and I could actually work out there's a relationship between them, because if I take 2 and I work out the negative reciprocal, I get 2 gives me minus a half. And if I work out that one, which is the negative reciprocal, well, negative is going to make that positive, so it can be positive. And let's work that one out. So that's 1 over 1 over 2. How do I resolve this? Well, some people just say you put that number on top. But let's see why, because they are right. This means 1 divided by a half. And if I do that as a sum, it's going to be 1 multiplied by 2 over 1. We switch the sign and we flip the sum, and 1, 2 is 2. And so the reciprocal of minus a half is going to be, here the negative reciprocal is going to be plus 2. So it works both ways. Okay, we've got then some ideas. But what would happen if someone gave me a graph and they said, can you try and draw this graph? So let's have something. We'll have y equals, let's go for 3x plus 3. Now, there are ways of trying to draw this out with tables, and we could do that. We could take our x value, and let's just take 3 or 4 numbers. So let's take minus 2, 0, and plus 2. I could work it out for more, but we needn't. So I'm going to work out now what 3x is going to be. So this is going to be 3 times minus 2 is minus 6. 3 times 0 is 0. 3 times 2 is 6. And then we want to do the plus 3. So this is now going to be the 3x plus 3. So minus 6 plus 3 is going to give me minus 3 plus 3, and 6 plus 3 is 9. So I could plot those values. We only really need 3 values to work out a line. So let's see if I can work out enough. So if I say that's going to be 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3. I nearly made my line long enough. I made a guess. And here I'm only going to go from minus 2 to plus 2, so it's not going to be a terribly wide graph. And at minus 2, it's 1, minus 2, 1, 2, 3, minus 2, we're going to have minus 3. At 0, we're going to have plus 3, and at 2, we're going to have plus 9 right up there. So let's now draw in these points, and in fact we'll see that these do in fact all line up with one another. And there's my graph drawn. I needn't have done it that way, because let's see what I could have done instead. I could have said y equals 3x plus 3. So let's bring that down here. What do I know about y equals 3x plus 3? Well, it's going to cross the y-axis at plus 3. And my gradient is going to be 3. The gradient means the rise over the run equals 3, or 3 perhaps over 1. So if I take my point here, 3, I go cross 1 and I go up 3, you can see that I'd have ended up with 2 points, and I could have checked them by putting in perhaps a third. I could have gone down here and across, and it's still going across 1 up 3. So I can draw a line in this way. Let's do it. Y equals a third x plus 2. Let's see if we can just draw that line in just by having a graph. And we'll just not do a set of tables and do this. So I've got my numbers 1, 2, 3, 4, 5, so on. Let's see what we've got. We've got y equals a third x plus 2. So I know it's going to go through the point 2. Done that. Now it's a third. We know it's positive, it's going in that direction, and a third means it's going to go along 3 and up 1. So I really want to do this again, along 3 and up 1. 3 points is good for trying to draw a line. And there's my graph drawn. So we can use y equals mx plus c, or if you prefer plus b, to work out virtually any straight line. And we can either do it with values to try and help us, or we can use just really this system of looking at it. Let's look at another one. They might ask me to find or draw in the perpendicular line to another one. So let's draw in another one. Let's have y equals, oh, how about a quarter x minus 1. What does that mean? Well, let's just put in some numbers, and I'm going to go and make sure here I've got my minus 1 and minus 2 there. And I've got some numbers going along this side. Right, minus 1. It's going to go through the line at minus 1. And it's a quarter x. So it goes up 1 along 4. So up 1, 1, 2, 3, 4. It's going to go there. Let's do another point. 1, 2, 3, 4. And up 1. So here is this graph. Maybe it asks me to say, can you draw in the graph that is at right angles, perpendicular to this, that goes through the point x equals perhaps 4. So I'm going to use my 6 because it's got a long line on it. And I could draw in my graph. There's the perpendicular to it. It's going to be at 90 degrees. Let's work out what this is going to be. This is going to be y equals the negative reciprocal of a quarter, which is going to be minus 4x. And so I can see that this one is going to be minus, it's going that way. We can see it's sort of coming down as being a negative, coming down this sort of way. So what we've got is here 1 across and 1, 2, 3, 4 up. And that's what it is. Now, where's it going to cross this axis? Well, let's see what we know. We know that this crosses at this point, where x is going to be 4 and y is going to be 0. So I could just put these numbers in. Let's do that. So I've got y equals minus 4x plus, I'm going to call it c. I want to work it out where it is, and we know the values are going to be 4, 0, our x and our y. So I can say that 0 equals minus 4 times 4 plus c. So that's going to give me 4 4s are minus 16 plus c. I want to work out what c is, so what I'm going to do is I'm going to take this over to the other side. To do that, I need to do the same thing to both sides. I'm going to add 16 to both sides. That's going to cancel out, and so I know that c equals here 16. My equation then becomes y equals minus 4x plus 16, and that doesn't appear on my graph, but we were able to work it out anyway. So we can solve these things graphically, or we can solve them without a graph. with a graph is usually easier, but when I've got this idea of y equals mx plus c, or b, can be a, doesn't really make any difference, we can solve these sort of equations and work out some things about a line. Now, if you're asked to try and work out this formula, but you're given now a couple of points, and they may say, okay, here's my little graph, and what we've got are a couple of points. Let's suppose we go through the point 2, 3, and let's go through another one which is 4, 5. Can we work out the graph of this line? Well, there's easy ways of doing this. So let's look at the point 2, 3. So it's going through, always it's x first and then y. So the x value here is going to be 2, the y value is going to be 3, and the next one we've got is 4, 5. The x value here is 4, the y value is 5. So I've got a line that goes through here. Let's see what we could actually determine about that. Well, I've got a gradient here going along one and up one, so that's going to be y equals x, and it goes through 1. We can solve that in a different way. Trying to solve this a different way, we can look at a different formula, and this one I know as y2 minus y1 all over x2 minus x1. How does that work out? Well, these values here are x and y. These are the first values, these are the second values. So y2 is going to be 5 minus 3 all over x2, which is 4 minus 2. 5 minus 3 is going to give me 2. 4 minus 2 is going to give me 2. 2 over 2 gives me 1. So I can therefore write out this is going to be y equals x. But I don't know where it's going through, so let's take one of these two sets of values. It's entirely up to you which ones you use. I'm going to use this set, and I'm going to use this set simply because they're easier numbers to work with. So what we've got is a formula, y equals x plus c. We know what y is, it's 3 equals x, which is 2 plus c, and now I can work out that. Let's take away 2 from both sides. 3 minus 2 is 1 equals c. So my equation becomes y equals x plus 1, and that is the same as we got when we did a graph of that same thing. So it's quite easy really trying to do some of these questions. So what happens when you do get a question? You say, yeah, well, it's a bit different when you get a question. So let's see if we can draw an equation for a line. So we get some of them that start, copy and complete this table. We've got a table with x and we've got y in here, and where values are going to be -2, -1, 0, 1 and 2, and we've got to complete this for a particular line because we want you to try and draw this, and it might be something like y equals 2x plus 3. Now, I wonder if you've got a calculator handy, because if you have a calculator handy, then we can do some wonders with this. If I select the menu, and what we do with this is we choose here a table, then it says f of x, some sort of function of x. Y is going to be some sort of function of x, and that's going to be 2x plus 3. So it's going to be 2 and then x plus 3. Do I have another graph to draw? No, I don't. So I'm just going to basically go on. Where would you like to start? Well, we're going to start here at -2. Where do I want to end? I want to end at +2. And I'm going to go up in ones, and that'll do nicely. And there it draws the graph out, and I put the screen up here, and we can see ready to complete the table. So at -2 it's going to be -1. At -1 it's going to be 1. At 0 it's going to be 3. At 1 it's going to be 5. And at 2 it's going to be 7. I could have worked this out manually just as well by working this out. I'll just do that for you just to show you how I would go about it. So this is going to be 2x, so 2 times -2 is -4. 1 times -1 times 2 is -2. 0 times 2 is 0. 1 2 is 2. 2 2s are 4. Now we're going to add 3 to each of these. 4 plus -4 plus 3 is -1, and then we go on and we get exactly the same. Now, could you draw this graph out? So let's draw a line in. We're going from -2 up the top here, -2 to +2. So -2, -1, 0, 1, 2. That's all I'm interested in. And we're going to range from -1 to +7. So I'm going to go from -1 here right up to +7. I can either plot all these values, or I could just do this. So let's have a go at just doing that for a minute. My graph is y equals 2x plus 3. It's going to cross then at plus 3. And in fact that corresponds with our numbers that we've got. When it was 0, it's going to be 3. And it's 2x. That means we go along 1 and up 2. Along 1 and up 2. And draw the graph in. And in fact, if I've done it right, it goes through -2, -1. And in fact, that is what we were looking at. Or I could have plotted the values. So, an alternative way of trying to draw a graph. So, y equals mx plus c seems to be quite an easy way of trying to draw graphs. You can take your pick whether you want to use y equals mx plus c as we do in the UK, or other countries where they use y equals mx plus b. It's only a letter. The idea, the maths is exactly the same. I hope you've found this useful. If you have, then please subscribe and give us a thumbs up. Always helps. And I will see you next week when we do some more GCSE Maths topic by topic. Until then, take care and stay safe. Bye bye.